Up above Earth, far from the safety of solid ground, hangs an instrument that has transformed our understanding of the universe, the Hubble Space Telescope. Launched in 1990, this telescope has forever altered the way we see space, allowing us to peer into distant galaxies, uncover the secrets of dark matter, and even map the very edge of the universe. But Hubble's story almost ended before it had truly begun. After its launch, an unforgiving flaw in its main mirror threatened to undo everything. What seemed like an insurmountable obstacle, however, became a turning point in human space exploration. In an extraordinary mission, a crew of astronauts would face the impossible. They would fly into space and repair Hubble, performing complex surgery on a highly sensitive piece of equipment in the cold, weightless void of space. The Hubble Space Telescope was a dream decades in the making. Designed to look deeper into the universe than any telescope before it, Hubble's mission was simple, yet revolutionary: to unlock the mysteries of the universe by seeing farther than ever imagined. Its birth came after years of planning, and its launch was heralded as one of the greatest achievements in space exploration. Unlike ground-based telescopes, which are limited by Earth's atmosphere, Hubble would orbit above it, where light pollution, atmospheric distortion, and weather would no longer be obstacles. From its vantage point, it could study galaxies, stars, and even exoplanets with unparalleled clarity. Its first images, released in 1990, were nothing short of a breakthrough. The sharpness of Hubble's views revealed nebulae, galaxies, and star clusters in incredible detail, offering insights into the formation of stars, the age of the universe, and the expansion of space itself. For a brief moment, it seemed that nothing could halt the promise of this space-based observatory. But in the days following Hubble's launch, disaster struck. The first full-color images from the telescope arrived on Earth, but they were blurry, indistinct, and out of focus. Hubble was not performing as expected. Astronomers were stunned. The telescope's mirror, the most critical part of its imaging system, was supposed to capture light with perfect precision, but something was terribly wrong. Initial investigations revealed that during Hubble's construction, a flaw had been introduced, a microscopic error in the polishing process. A subtle misshaping of the primary mirror meant that the light Hubble gathered could not focus properly. It was a heart-wrenching realization for NASA. The telescope's ability to fulfill its mission of unlocking the universe's secrets was compromised. Scientists, engineers, and the public grappled with the devastation. Hubble, a marvel of modern technology, was now rendered nearly useless. In the face of this setback, NASA decided that nothing could be left to chance. They would not let Hubble's potential slip away. Instead of abandoning the telescope, NASA proposed the unthinkable. They would send astronauts into space to fix Hubble. A team of elite astronauts would travel on the Space Shuttle Endeavour, rendezvousing with Hubble to conduct a series of delicate repairs. The Space Shuttle's robotic arm would be used to maneuver astronauts in their EVA, extravehicular activity, or spacewalks, allowing them to install new components to correct Hubble's optical flaw. But performing these repairs in space was not only difficult, it was incredibly dangerous. There were no guarantees. The astronauts would be working in a hostile environment, completely exposed to the vacuum of space, where even the smallest mistake could lead to disaster. The astronauts chosen for this daring mission were not just explorers, they were pioneers. They faced a challenge unlike any other: to repair the telescope in the dark void of space. They were tasked with carrying out what was essentially space surgery on one of the most complex pieces of machinery ever built. Story Musgrave, the mission commander, was an experienced astronaut. having flown on 6 space missions. His calm demeanor and unparalleled knowledge made him the perfect leader for this team. Alongside him were Kathy Thornton, a seasoned astronaut who had previously completed spacewalks, Ken Bowersox, an expert in spacecraft operations, and Steve Smith, a veteran spacewalker with extensive experience in space-based repairs. Together, they would train for months, rehearsing in a giant neutral buoyancy pool, where they practiced the repairs underwater, simulating the zero-gravity conditions they would encounter in space. Despite the rigorous training, nothing could prepare them for the sheer difficulty of working in space, where even a simple task could turn life-threatening. The success of the mission would depend on precision, teamwork, and absolute focus. Spacewalks are one of the most dangerous activities a human can undertake. The astronauts would need to leave the safety of the shuttle, step into the cold, airless void of space, and work on a delicate piece of machinery. They would be exposed to cosmic radiation, extreme temperatures, and micrometeoroid hazards, small particles traveling at incredible speeds that could puncture their suits. With no atmosphere to shield them, they would be completely vulnerable to the harsh environment of space. The delicate operations required to fix Hubble's mirror would demand an exquisite level of precision. The astronauts would use a specialized tools kit, designed specifically for use in space. But these tools weren't just for fixing Hubble's optics. They were lifelines, designed to help them carry out the repairs without losing their lives in the process. On December 2nd, 1993, the astronauts aboard Endeavour began their mission. As the shuttle slowly approached Hubble, the crew readied themselves for the monumental task ahead. Their first challenge was to carefully remove Hubble's faulty mirror assembly. Every move had to be precise, every action calculated. Steve Smith and Kathy Thornton exited the shuttle, tethered to the robotic arm. With meticulous care, they used tools to detach the damaged optics and prepare for the installation of the new wide-field and planetary camera 2. It was a difficult operation that lasted for hours, but they succeeded. Slowly, the crew replaced the faulty equipment, fitting the new optics into place. The installation was just the first step. The team also performed several additional repairs to ensure that Hubble would continue functioning for decades to come. After the repairs were completed, Hubble once again began transmitting data. But this time, it wasn't the blurry, distorted images of the past. It was crisp, clear, and breathtakingly detailed data. For the first time in years, Hubble's vision was restored. And as it peered into the depths of space, it captured images of galaxies, nebulae, and stars that were far clearer than ever before. Hubble would go on to revolutionize our understanding of the universe, from the age of distant galaxies to the formation of stars, and even the exploration of distant exoplanets. The STS-61 mission was an unqualified success. Hubble, once seen as flawed and irreparable, was now the greatest tool in humanity's cosmic arsenal, showing us the universe in ways we could never have imagined. The repair of Hubble was more than just a technical achievement. It was a testament to human perseverance, ingenuity, and courage. It demonstrated the power of cooperation and the capacity of humanity to confront the unknown, to solve problems that once seemed impossible. Today, as we prepare to launch the James Webb Space Telescope, Hubble's legacy lives on. The telescope may be old, but it has paved the way for future missions, pushing the boundaries of exploration and scientific discovery. Hubble showed us that no challenge is too great, and that, no matter how distant the stars, we can always reach further. The cosmos is vast, but the human spirit is even greater.